We'll see how to do meshing in Pointwise. First, we'll import the geometry. Go to File, Import, and Database. Here is our SolidWorks part. We'll click on it. Select Open. Basically, Pointwise is compatible with most of the CAD domain, CAD software, so this won't be an issue. Here we'll select the units. For this particular geometry, we'll keep it from file. So it will use the units mentioned in the CAD file, or we can else change the units. We'll click on OK. So the geometry is being imported. Okay. Here, if you see, this is geometry and this is the wireframe. So to visualize this, we will select all and go to this box, select shaded. So this is our geometry. Here, if you on the left hand side, you can see the database cut. Now the next thing is to create connectors, and to do so, we will, as you can see, the connectors are 0. We will select all and click on this icon, connectors on database entities. If click on it, you see it creates the connectors. So basically these lines, these are the connectors. 28 connectors has been generated. And now the next step would be to assemble quilts. So quilts are basically some kind of surfaces. If I click on the rainbow, you can see these are the quilts. So for the meshing, we'll need a uniform surface, and it is better if we can assemble the quilts before meshing. So what we'll do, we'll select all the geometry. We'll go to the create, assemble quilts. Here we can see there are 8 quilts and 18 lamina boundaries. Lamina boundaries are there, so it should be 0. If it is there, that means our geometry is not watertight. So what we can do, first thing is we will create a uniform quilt or reduce the number of quilt. Let's say we'll change the angle by 30. So if angle is less than 30, it will count as a 1 quilt instead of 2. I'll unassemble. We can check with it. So here number of quilts get reduced, but still we have some quilts. We can reduce this, let's say by 5. So it's there. P. Okay. So yeah, it is okay. I will keep it as it is. We'll click on OK. Now the next step would be to click to generate the surface meshing. So we'll select all. We'll go to create. an automatic surface mesh. Here you can play with the parameters, global surfaces boundaries. You can change the resolution also, like by changing the minimum subdivisions or minimum edge length. You can generate coarse or fine meshes here. You can change the goals also. You can change the algorithm to hybrid, which will take quad mesh and tetrahedral mesh also. Here we can limit aspect ratio, area ratio, and all those things. So now we will click on create surface mesh. Yeah. Mesh has been generated. Here you can see it's quite good. Later, if we need any refinement, we can do that also. Okay, cool. Now we'll click on OK. Is the thing to rotate the object. Click right mouse button and control, and to pan it, use shift and right mouse button. So after doing this, the domain has been created. Here you can see quilt 1, quilt 2, and this domain. Next thing would be to create a volume mesh. Yeah. So to do so, we'll select all again, go to the create, then automatic volume mesh. Here there are two options. So either for external flows, we'll go with the first option. But for this example, our flow is the internal flow, that some fluid is going through this domain. So we'll use the second option. Okay. Here they're giving us the volume, so giving us the error that there are some free edges and that need to be taken. So they may prevent you from creating a watertight volume mesh. So we'll say no. We'll first look into that. What is the error? So we'll first create, you'll select all, we'll go to the grid, and then there is option of merge. Here there are 43 free surfaces. Here you can see with the red, and to we want 0 here instead of it. That it creates a discontinuity in the mesh. So we'll do that by changing this tolerance. We'll put 0.1 value, but before that we can check how where are these gaps are. So from here you can see how much is the gap and how it is. So we'll just close. We'll select all, go to the grid, merge. Now add the tolerance 0.1 maybe. You can play with it also, and click on apply. Let's wait for this. Okay, free surfaces are now 6. Let's click OK and see if it is uh, creating a volume mesh. Click on volume mesh, use existing volume mesh boundaries. Yeah, it's going. Now there are two options for interior mesh. First is unstructured volume mesh. Second is voxel volume mesh. Voxel is like a snappy hex mesh if you are using OpenFOAM. So we'll select voxel. We can also generate a boundary mesh. We'll click on geometric growth. For now, we'll use this parameter as it is. Later on, we can change if you want. So we'll click on, and here also there are other options. We can play with it, but for now we'll keep it as it is, and we'll create volume mesh. The volume mesh has been created, so it's pretty fast. I'll just click OK. Now the main thing is to initialize the mesh. So to do so, we'll click on the block. A block has been generated because of the volume mesh. We'll click on the block. We'll go to grid and then solve. Now here also there are many parameters. T-rex is also one of the uh, main important parameter to look into if you want a finer mesh uh, or good quality mesh. But for now, we'll use the same, and we will initialize it. Now it's running. So basically, what I like about this software, it's uh, very fast, and we have the control on the meshing. Let's see. Okay, I think see. Okay. Yeah, the mesh has been generated. We'll click on OK. You can see here. So for now, we'll click on OK. Now to visualize this mesh little bit more clearer, we select all, we go to view, and we hide the database. Now you can see it more clearly. Now uh, to export in the desired mesh file, we'll select all. We'll go to CAE, select solver. So for now it is CGNS. We'll change it to maybe OpenFOAM. Let's see where it is. Yeah, I'll double click on it. We'll again go to CAE, set dimension, it's okay, it's 3D, set boundary conditions. So here all the boundaries are unspecified. So we'll click on new, and now we'll select one boundary, this. We'll name it as a output or outlet. And select, we'll click on new base boundary. Okay, inlet, new, this surface, this surface, this surface. What is, okay. We'll name it as a wall. Okay. It has taken inlet also. So we'll just select, we'll go here, inlet. So now we have our outlet, inlet, and wall. That's pretty good. Now we can also change the CE type. Like our outlet is patch, inlet is patch, wall is wall. We'll close it. We'll again go to CAE, set volume conditions. We'll create new volume conditions, unspecified. Okay, so here, let's see what it is. We want all the information. So we'll click on the last option, close. Now, one more thing is to see the meshing or mesh count. We have to do this following steps. First, we'll select uh, all the blocks or domains. Then go to the grid cell count. So here, if you see, total cells are like 2.8 million, 28 lakhs. We'll close it. And one more thing is like examine volume and cuts. So we can see the mesh very accurately here, and we can refine it if we need. We'll click on enable cutting. If you see, this is the mesh internally. We can shift this plane little bit to the left side. It's fine. Okay, that's okay. And then we'll save it. We can also change whatever we want. If we want skewness angle, we'll click on that, and here I showing how it is. The maximum value is 0.99, and if you click on this, it will show where this is. So this is on the boundary, so we can neglect it, or if you want to work on it, we can do that later. So there are many options, and also click on aspect, see the aspect ratio. It's pretty much Okay, we can check whatever we want. We'll close it. And now, uh, as we have already assigned some inputs for the CE solvers and also assign boundary conditions and all those things, we can export the mesh. Here you can here you can see that we are using CE solvers as open form. So we'll click on File, Export, and CE. Now we need to create one folder like polymesh, which and select the folder. Now uh, it's creating sorry, so it's creating the mesh file. Now we'll wait for it. Okay, it's done. Let me just share to you what it is. Okay. So if you go to that folder polymesh, it creates these files like that. We have boundary as there in open form. So inlet, outlet, wall. You can just paste it in the constant folder and run paraview. It will show you the results. Okay, thank you.